Today's lesson is about properties of rational functions, and I'm going to break it up into two parts. We're going to look at it graphically and then just algebraically. Some of the main terms that we're going to need to know are just what is a rational function? It's any function that has an x in the denominator like this. The domain of a rational function. What is a horizontal intercept? That's usually called an x-intercept, but in WebAssign you will see that word horizontal intercept. Then a vertical intercept is also usually called our y-intercept. We do have horizontal asymptotes and vertical asymptotes. And in another lesson, we'll learn about slant asymptotes. And then lastly, there are holes in a graph sometimes. So when we look at this graphically, we want to first maybe identify some of these asymptotes. And so an asymptote is just where a graph is approaching, but it may not actually equal that value. So I see these vertical asymptotes that are going on here and here. A vertical asymptote is an x value that's undefined for the function. So I see a vertical asymptote at -4, and we would write it as x equals -4, and the other one is at x equals 5. You do have to include the x equals. You will not get all your points if you only put -4 and 5. It's an equation, so we need the actual equals to it. The horizontal asymptote is where the function is approaching on the ends of the function. So it may actually equal that value at some point, or it may not, depending on what's going on in the graph. So this one has a horizontal asymptote at 1, 2, 3, at y equals 3. If we look at the graph, we can see that it does cross over that asymptote right over here, but that's okay. It's still going to be approaching 3 on the end. So if we were to describe the end behavior as x goes to positive infinity, the y values are going to be approaching 3. And as x goes to negative infinity, the y values are still going to be approaching 3. Now an x-intercept is where the graph crosses the x-axis. We see one here at -3 and another one at +2. So our x-intercepts are -3, 0, and 2, 0. The y-intercept is just under +1. So we can estimate that's about maybe 0.9. And then there are no holes in this graph. When we look at the domain, this is going to come from the denominator of our rational function. If it's graphed, then we're paying attention to the vertical asymptotes and any hole that's in the graph. So we see two vertical asymptotes at -4 and +5. That means our domain is going to go from negative infinity all the way up until we get to this first asymptote of -4. Union -4 all the way up until we get to 5. Union 5 to infinity. So algebraically, we may need to actually find these. The asymptotes, the vertical asymptotes are coming from the denominator here. If we want to find the y-intercept, this was the one that we had to really estimate. That's just the value of y when x is 0. So I'm going to plug in 0. 0 plus 3, 0 plus 4, and 0 minus 5. And we'll see how close we were just by that estimation. So 3 times 0 minus 2, 0 plus 3, over 0 plus 4, and 0 minus 5. So I got 9/10, which is exactly 0.9, so we were really correct. So we can check it algebraically if we need to. When we look at this second graph, this is what we're talking about, there being a hole in the graph. Now, this is not always apparent, but if we have the equation, we know that it's true. That whole is coming from where there's a common factor on the top and bottom of the rational function. So this whole is going to happen at -4. And you'll have to estimate what that y value is. It's just above -1, so maybe -0.9 for us right now. And that's just an estimation. We'll talk about how do I find that algebraically in the next video. The x-intercepts, if I look here for when it crosses the x-axis, there are none. The y-intercept is right about there, which is maybe -1.7-ish. So 0, -1.7. The vertical asymptote I see here at +3, so it's x equals +3. And the horizontal asymptote, remember, it's not always going to give you this dotted line, so just kind of look for where is the function flattening out, if it is. And we can see how it's kind of flattening out as it gets closer and closer to 0. So that's where the horizontal asymptote is, y equals 0. All right, and we talked about how the domain of the function is all the x values. A whole is going to take out one of those x values. So that means that -4 is going to be excluded from the domain. But we have a vertical asymptote at 3, so that's also excluded. Our domain would say -infinity all the way to -4, union -4 to 3, union 3 to infinity. So we're only worried about the x values when we're referencing the domain. Okay. So you could pause the video and try these two, and then press play when you're ready. All right, if you've already tried these, what you'll notice about this third one is that there's no horizontal asymptote. The function is not flattening out at any particular part. That's because what we actually have is a slant asymptote that's going this way. We don't really know how to define that algebraically yet, but we will learn. So the x-intercepts, where it crosses the x-axis, is going to be at -7 and +3. So -7, 0, and +3, 0. The y-intercepts, I can't even see the y-intercept, but there is going to be one because as the function is going up, it's eventually going to get closer and closer to that asymptote. So it does cross over the y-axis at some point. So this I would have to find algebraically. So I'll plug in 0 for all my x's. And then just plug that into our calculator. So this would say 0 plus 7, 0 minus 3, 0 plus 2. On the bottom, 0 minus 1, and 0 plus 2 again. Gives me 21, so the y-intercept is 0, 21. Now that whole is happening at -2, and that's because we have a common factor of x plus 2 on top and bottom. So if I want to find, I'm going to have to estimate what the actual location is, but it's about 8 point something, so maybe 8.1. If we have the equation here, we do need to find that algebraically, but we'll do that in a second. So the vertical asymptote is happening at +1. That's an x equals, so it's x equals +1. The domain is coming from all the excluded x values. The first excluded value is going to come at that -2 where the whole is. So we go all the way to -2 from -infinity to -2, union -2, and then all the way up to that vertical asymptote of +1, union 1 to infinity. The last one here has lots of asymptotes. We can see all these vertical asymptotes that are going on. So here's one at -5, another one at -2, and then another one at 6. So if you notice what's happening in the denominator, all of these factors in the denominator are creating these vertical asymptotes. So there's one at x equals -5, another at x equals -2, and another at x equals 6. The horizontal asymptote is happening here at -3, but it's on the y's, so that would be a y equals -3. As I look through the graph, I don't see any holes in the function. It's just continuing on. And that's because if I look at the function, there's no common factor on top and bottom. So there are no holes. I can find our x-intercepts. It's where it's crossing. I see at -3, there's an x-intercept. And then we have another one, and it's up here at +2. Notice that it's bouncing off the axis at that point, and that's because really this is x minus 2 and x minus 2. You could have rewritten this as x minus 2 squared. So there's our multiplicity where it bounces. And then the y-intercept. I can estimate that it's a little bit above halfway, so maybe 0 and then 0.6. But if we want to find it algebraically, we do -3 times 0 minus 2, 0 plus 3, times 0 minus 2, all over 0 plus 5, 0 plus 2, and 0 minus 6. We'll plug that into our calculator. 0 minus 2, 0 plus 3, and 0 minus 2 again. 0 plus 5, 0 plus 2, and 0 minus 6. Okay, so we get 3/5, and if you make that into a decimal, it's actually 0.6, and that was pretty close to what we guessed. The domain comes from all the x values that are excluded. There are no holes, but there are vertical asymptotes, so these vertical asymptotes are going to affect the domain. I go from -infinity all the way up until that -5, union, -5 all the way until we get to the next asymptote of -2, union, -2 all the way up until 6, union, and then 6 to infinity. In the next video, we'll look at how do we find all of these things without a graph.